thanks for the introduction. So we also will have a guest appearance from Sean Murphy from University College Dublin. So he'll present at the end short part. So thank you for having us here, and I'm going to start with my talk regarding the delivering in-vehicle infotainment system based on Tizen and Ford SmartDeviceLink. So maybe I'll start with a few words about us. So myself and Jacek are the co-founders of the company called Zilia. So we both did our degrees in Poznan University of Technology. I did also a PhD in Dublin City University, Ireland. So maybe it's a bit off topic, but it's an interesting story about our company. Since 2008, an American company, Telcordia Technologies, had a R&D branch in Poznań. So myself and Jacek were working in that branch of Telcordia Technologies, and we were working on really cool projects, mainly R&D funded by the European Union and also Polish funding agencies. And in 2012, a little company that you probably heard about called Ericsson bought out Telcordia, and they decided because they have kind of strong presence in Europe, they decided that the kind of branch in Poznań, especially that Ericsson doesn't really have any R&D and development in Poland, so they decided to kind of sell or close the branch in Poznań. So we kind of gave them an offer, couldn't refuse. So we did the buyout of the company. So we, from the Telcordia Technologies / Ericsson, we bought the branch in Poznań. So we're actually running it with success, having different R&D projects and also working with commercial partners on research work. So what are we doing? So main interest of Zilia is embedded software development. So we develop software for different embedded devices, mobile phones, also set-top boxes, onboard devices in the car. So IVI and telematic systems, it's in our field of interest, and we also have good expertise in speech recognition and digital signal processing. So we're working with our partners on research project in these areas. So this work that we're going to talk about today was made within the CarMesh project, and CarMesh is a project from the European Union FP7 Marie Curie program. And it's based on IAPP scheme, which is Industry, Academia, Partnership and Pathways. So in this scheme, in this project, we were the partner from the industry, and University College Dublin is the second partner in this consortium that actually is an academic partner. So the work in this project was based on secondments, so the exchange of researchers. So some of the researchers were coming from Dublin to Poznań. We were going there, working on a joint project, and the main kind of focus of the project was the delivery of advanced automotive services to the connected car. The project was kind of split in three parts. So there were networking aspects, mobile car integration area, and integration with cloud services. So maybe based on a kind of picture, I'll tell you. We did work in this project in all those fields. So access network, this was done mainly through simulations, emulations, and in cloud services we were working on an automotive platform for the systems. But today we're going to talk only about, because the audience today is mainly software developers, mobile developers. So we're going to only focus on the part of the project which relates to the integration of the between the car onboard unit and the mobile device. So the talk's going to be split in 3 parts. So I'm doing the introduction and kind of the context of the evolution of the connected car and some future trends that we envision. And then Jacek will give you an overview of open source automotive platforms and give you some demos of the systems that we were using for our prototypes. And then Sean at the end will present SmartDeviceLink, which is a new standard pushed by Ford that actually allows you to have synchronization between the onboard unit, so an embedded computer in the car, and the mobile device. Okay. So why connectivity matters in the car? So there's simple examples. So we were coming here, for example, from Poznań yesterday, and I was using the standalone navigation, and Sean was using his Google phone with always-on connectivity. So in the end, it ended up that half an hour difference regarding the expected arrival time was on the standalone navigation, and the phone with online traffic information and current road data actually gave accurate information of our arrival time. So it clearly shows that online connectivity for the car is really something that's important, and it would show and will change how this environment and all the applications work. And it's not only about real-time data, but also integration with social networks and creation of novel applications, which are possible only when you have always-on connectivity in your car. So looking through the market research nowadays, it's estimated that by 2025, 60% of the cars on the road will be internet connected. It's envisioned that the automotive application market should reach $1.2 billion by 2017. So it's clear that the kind of automotive sector and also the mobile world sees the connected car and the new ecosystem that is just starting to shape up as a big opportunity for new services and revenue. So the term of the connected car was coined some time ago, but what it really actually means. So it's actually a mix of different technologies, interfaces that enable in-car internet services integration. So I think it cannot be really defined with one definition. It's actually a mixture of different technologies that allows you always-on connectivity for the car. So it's probably software mobile developers' point of view. So why not get rid of this car part and just we can imagine that the car manufacturers would just leave an interface there in an empty space for a tablet or a smartphone and just get rid of the whole onboard unit part. But there's a lot of kind of hurdles and reasons why this onboard unit will always be there, and there will need to be an integration between the mobile device and the onboard unit. So some of them are safety regulations. So those IVI systems they need to fulfill a lot of different regulations to be in line with driving safety, and the quality assurance process for automotive software is also very, very strict. There's also needed the integration with car onboard interfaces. So you need the feedback, you need the control from the steering wheel to use the speakers in the car, the microphone which is provided, and the multimedia display that's already in the car. And also auto manufacturers, they want to kind of have revenue on this new automotive applications market, and they want also have some control over this ecosystem. And of course, there are some security issues regarding the car data and functionality that needs to be kind of locked from mobile developers. So some functionality of like remote engine start and others which are needs to be kind of keep locked only for certain use. So in the project, we kind of started off with saying that the mobile device will play a crucial role in the connected car concept. This will be the kind of the main focus, and the whole intelligence will be actually on the phone. And the phone will be the gateway to the internet and to the external networks. So the mobile car integration in this system is really a crucial aspect. And different car manufacturers have their own way of realizing the connected car vision. So there's some basic integration which was done over the years, and it's only you can send over some contacts, and you can support hands-free calling from the car using the hands-free set. So this is what's already there. Nowadays, like there are also another aspect is that the car manufacturers want to have the majority of the control of their application. So, for example, Mercedes, they teamed up with Google to kind of build a prototype of a system. But they actually released the mobile app to control their IVI system, and they have the full control over it. So it's not an open API. And another trend kind of in the industry is all the mirroring solutions. So you basically have your mobile phone, and the phone connects through USB or Wi-Fi to the onboard unit. And kind of the screen is mirrored on the OBU, on the multimedia display in the car. So there's the technology called mirroring that enables this functionality, and also the features of the new iOS 7, which allows you to kind of mimic the screen on in the car. But what we're most kind of interested, and what we kind of used for our prototypes and development, was more advanced solution of car mobile integration, which is, for example, Ford SmartDeviceLink protocol, which is kind of an open standard pushed within the Geneva Alliance. And they actually open up the whole code source to the developers and allow you to create your own applications using the API. So this is what we liked, and we actually use this technology in our work. So as I said, so the application runs on the phone and connects wirelessly to the car. And HTML5 is also a big factor here on the OBU. So the OBU system that will work with this car integration solution needs to support HTML5 and web applications. And of course, if you develop applications using these technologies, they should be designed to minimize driver attention. So just quickly, what you can do if you have this always-on connectivity, and the phone is kind of your gateway to the internet. So you can use both the data that is generated by the car and the data that is stored or analyzed in the cloud to kind of develop new and innovative applications. So some of these applications that are actually already starting to appear on the markets, for example, the first one, which is car insurance companies are interested in, that you can have your own application on your phone, and you turn it on always while you're driving, and they kind of record your behavior, how you drive, if you're a safe driver, and based on this they can use kind of dynamic pricing for your insurance. So this is one kind of cool application that it's possible with these technologies, and it's also there's market for this, and companies are interested in this. So other applications that you can develop, for example, you have the position from the car, and also you can combine with your calendar, like Google Calendar. Then the navigation can sort of plan your route according to the meetings that you have. So this is one of another app. There's more applications. If you have the diagnostic data from the car, you have some driver behavior analysis software in the cloud. Then you can also have dynamic pricing for car rentals, for example. And for electric cars, I think it's also a very important market for the connected car, because the car manufacturers are not really sure. They're just releasing the first electric cars, and they want to gather as much data about how they are used and how durable they are as they can. So this is also some applications that can be developed using this toolchain. So I'll pass over to Jacek, and he will talk about open source automotive platforms, and we'll show you also some demos of the technologies that we used.
Thanks. So regarding this slide, one short notice. For example, in California, I had a chance to talk to guys who are integrating different automotive platforms, and they said that the first use case cannot be fully developed because according to California law, the insurance company cannot use the data from the driving experience, the driving behavior, to increase the premiums. They can use, if you allow them, only if you specifically allow them to use the data to lower the insurance. So just a short notice. So going forward, it's not this computer, sorry, it's this one. Going forward with automotive platforms that are already there. So there are some of them which are closed, which you do not have access to the code. For example, Ford AppLink, which is the same as SmartDeviceLink. It's a different name for different purposes, but there is an open API from Ford that you can use to build your own applications, which connects to the car, which uses buttons and a screen as an UI. So this is an API you can use to build both Android and iPhone applications. There is also a GM OnStar system, which is very similar to Ford AppLink. There is a platform from QNX, which is widely used by different auto manufacturers. We do not know a lot about this platform right now. We concentrated our efforts on the underlined platforms. There's also Renault R-Link and Mercedes platform, which are very closed, and both hardware and software are maintained in-house by these companies. There's also a platform from Tesla. It's done by NVIDIA. It's currently close to third-party applications, but it will be open in the future. There are some people who are trying to get the APIs by doing some strange things like maybe let's move on. There are some open platforms, one of which is Tizen IVI, which stands for Tizen in-vehicle infotainment system, and MirrorLink. So we're concentrating our efforts on getting Tizen IVI working and see how easy or hard it is to develop applications and run on IVI. There are some efforts by third parties to integrate these platforms into one, like for example is drivencomputing.com. They are moving, it's a startup which tries to integrate some of them. They started with GM OnStar and are moving forward with different ones as well. About Tizen IVI, why we think this is, let's say, cool. First of all, it's open source. It's supported by major players, Samsung and Intel. It's already demonstrated, a proof of concept has been demonstrated by Jaguar Land Rover. It is based on Linux, and it got a lot of support from Linux community. Communication with the mobile phone is based on HTML5, unlike the Ford Appling applications, which is purely RPC. What to notice here is also it's supported by Genevieve Alliance, which supports all the stuff that is done by automotive guys, which connects to the mobile environment. So if you imagine devices in the car, you can notice that the lifetime of such device is much longer than a mobile phone, which you after 2 years you just throw your old mobile phone because it's getting old. Unlike this, the device in the car should stay, let's say it should work at least or up to 10 years. So it's increased lifetime and relevant if you compare it to mobile phone. And the Tizen IVI by design doesn't need frequent updates because it's purely based on HTML, and the interface won't change that frequent. Tizen IVI is using, you've heard a lot of presentation about Tizen earlier, so it's using Tizen web applications. There is SDK, full development toolchain you can use. Emulator as well is available. There are Tizen IVA snapshots available for downloading, testing, deploying, and using. Currently, you can use SDK version 2.2. This is automotive grade Linux. This is demonstrator developed by Linux community for user experience contest. It was also the one presented by Jaguar Land Rover. It works like this, as you can see on the right hand side. It's based on Tizen IVI 1.0. Currently it's 3.0. And I would like to give a short demonstration how this works in a virtual machine environment. So let me just quickly switch to the other computer. So this is how it works in reality. So you can imagine that this is the onboard unit that you can see on your car screen. You can tap multiple choices. You can have multiple choices like play an audio, play video, and so on. It doesn't work very fast because I have a lot of things opened. So this is everything here is on a virtual machine. You can imagine it running in the standalone device, embedded device. What's interesting for the driver are the measurements of the car, for example, how much battery level is left, what are the pressure levels in the tires, what is the temperature outside, or the weather forecast for the location you are heading to, and other as well. And it's also using CAN bus, so it's designed to use CAN bus to get data from the car. So switching back to the presentation. So to build an application for Tizen IVI, you can use, as I said before, Tizen SDK. You need to sign the application and upload it into running Tizen IVI image. whether is it in a virtual machine or embedded device. We are using VM Player for that. You can use the tutorial which I listed here to run the application, and I can show you how this works, because the Tizen AGL demonstrator that you've seen a minute ago, it's based on Tizen IVI, and it's you do not see what's happening underneath. So I need to switch to. The other. I'll need to open the other virtual machine, so it may take 1 minute maximum. Okay, it's this one, I think. You can. Oh, there are some differences between what you have seen within Tizen mobile presentations. So Tizen is designed to fit into different devices. So in majority, all the handheld smartphones, maybe laptops in the future. IVI, however, is designed to work with cars specifically. As I said before, it's using all the interfaces that cars have now or will have in the nearest future. As well, they use the HTML UI as a UI communication components. They are using CAN bus, and you are able to use the same applications, the same web applications in Tizen Mobile and Tizen IVI. Oh, it takes a while. Okay, maybe I'll come back to this later.
Yeah, so I'll do my talk stuff and then you can do that.
Yeah, all right.
Okay, so I'm going to talk about this technology which Piotr has mentioned, both Piotr and Jacek have mentioned. It's called SmartDeviceLink, and it's abbreviated to SDL. So I've got quite a few slides here, but time is ticking, so I'll go through them fairly quickly. So, an overview of SDL, what it is, why we were interested in it in the project, some of the working parts of it, issues we had with getting it going, some of the limitations of it. I'll talk a bit about, which is probably the bit that you're most interested in, which is like what is involved in developing applications using this technology, and then some final thoughts on what needs to be fixed with it, and where technology in the connected car context is going. So first of all, this was a slide that was dropped in at the last moment. Before this smart devicing technology, there was a technology from Ford called AppLink, which was about enabling the mobile to talk wirelessly to the car. This is shipping in 1 million cars today, and Ford are trying to promote it to the developer community specifically. So their idea is that developers can develop applications that run on Android or iOS, and that they can have access to some parts of the car, and they can get some feedback from the car. Okay, so that's actually a little bit different from what I thought. Okay, so it's being the technology SmartDeviceLink is being pushed within Geneva. AppLink was a predecessor to it. SmartDeviceLink is on the Tizen IVI version 3 roadmap, which is supposed to be released around about now, but progress on it is very slow. So we think this SmartDeviceLink technology is going to be integrated into some standard IVI systems. So I think that's why it's quite interesting. Here's a picture of the predecessor Ford AppLink. The phone is connected to the car using Microsoft Sync. There's a little graphic of the emulator tool that you can use for application development. The concept is the OBU is the user interface. Well, more generally, the car is the user interface. So the OBU provides some visual outputs to display. The buttons in the car provide input to the app running on the phone. There's callbacks triggered on the phone app when that happens. One of the stipulations when programming for this system is that the mobile phone screen should be locked. Again, this goes back to the driver distraction issue. This is something that Ford impose in their application approval process. So they remain part of the system, approving apps or not approving apps if they feel that they're not compatible with what they want to do. So that's applications certified by Ford. Ford provides development tools. It has an SDK, samples on an emulator. We've done a few blog posts on it, and it's the predecessor to this more interesting technology, but more earlier in the stages of development, called SmartDeviceLink. So what is SmartDeviceLink? Well, we claim that it provides a richer view of mobile car interaction than the mirroring solutions, which have been getting a lot of visibility heretofore. So the two most known examples of that are iOS 7, which Apple announced, I guess, 2 or 3 months ago, and MirrorLink is, for those of you who don't know, it's a phone car interaction technology, which has a lot of guys. Samsung are in there. Also a lot of car IVI guys are in there. So it's quite a big consortium, but it's taken them a long time. It originally started as a research project in Nokia, in fact. But it's taken a long time for it to get. Even now, it's only in aftermarket solutions. And I think there are some install options where you can, the dealer will install it in the car, but it's not really fully integrated with the car. So this MirrorLink stuff is still very new. Samsung have announced it in an application that they wrote called DriveLink, which they were promoting, that uses this MirrorLink technology for interaction with the car. Obviously, the car side has to support it. So relating to SmartDeviceLink, then it's different from the mirroring solution. The mirroring solution, you just see the whole phone display mirrored on the car display. With the SmartDeviceLink technology, individual applications can interact differently with the car, and in fact, it's possible to have multiple applications operating on multiple devices interacting with the car. So it's a much more flexible idea than this mirroring solution. SmartDeviceLink itself has a quite well-defined protocol right now. So Ford threw out a document which has a lot of primitives which define how the car and the phone can interact, and then there's been more people working on it. Although we feel that it's somewhat missing an architecture around it. So the breakdown of functionalities between the car and the phone is not very well defined. So one good example of that is around the navigation stuff. So navigation is stuff that's been very well solved on phones. There's really good technology to do it. And there's pretty good technology in cars to do it. But if you want to write an app for the phone which uses which interacts with the car and uses navigation capabilities, how does that work? The navigation systems on the car aren't open so that you can send destinations and point of interest to them, and then the car will pick up on that and route you, etc. But that's one example. But there are other areas where the split in functions between phone and car is not really well defined. why were we interested in this technology? We started looking at it earlier this year, and I guess first quarter this year. We felt it was the most open phone-car interaction solution. So the car industry, I suppose, is quite a closed industry, and some of the guys now are trying to open it up. A lot of the development that's gone on in the car industry has been very much embedded development. Out of the spotlight, they've got their own dedicated conferences, etc. Probably a bit divorced from a lot of the people that are in this room. So they are trying to slowly open up to be more developer friendly. Ford, we think, are kind of pioneers in this area. They really are trying to engage with the developer community, running hackathons, and there's stuff on Challenge Post. I think that Ford have a competition there to develop apps. So it's with the OpenXE. So they are kind of trying to engage. So SmartDeviceLink, we like where that's come from. Although we would add the caveat from a realistic perspective, MirrorLink has more industry support. So although it has more industry support, developer outreach is less mature. So they have a developer website, developer, I think, .mirrorlink.org, but it's been in stasis for the last 6 months. So they haven't really got even the documents out saying here's what MirrorLink can do and here's how you interact with it. Also, we really liked, from the project perspective, we liked the vision of the brains in the phone, the intelligence in the phone, and that's where the applications run, and then the car provides UI components, but also actually data. That's probably missing from that point. The car provides UI components, so the steering wheel, the buttons, etc., and that's very compatible with this SmartDeviceLink technology idea. So just some of the working parts that exist in it. So on the mobile, there's a SmartDeviceLink library, which has there's a separate one for iOS and for Android. Then it can communicate via either Wi-Fi or Bluetooth to the car. The car OBU then runs standard operating system level process called this SDL proxy. It's a quite it's a big enough piece of C++ code which just does protocol handling, message handling, etc. With the session management with the mobile. It's reasonably well designed in terms of robustness, etc. So when you turn on your SmartDeviceLink app, very quickly it's picked up by the OBU, and that's this SmartDeviceLink proxy doing its work. And then it has a WebSockets interface. It exposes a WebSockets interface to the HTML5 world. So the I guess most people have the vision that the user interface, the visuals are run in a browser. They call it the HMI, the human machine interface. As part of the system, they also provide a JavaScript library which is taking input from the WebSocket stuff, and again, it's doing the message handling so that callbacks can be triggered in the HMI to say that you've received button presses on the mobile app, and or there's some voice triggers on the mobile app that change the display on the on what you see in the car. So they're the working parts of the system. So I mean, this is just summarizing that. So the mobile has iOS and Android library. I put ish in parentheses there. There is a particular block of code that they have that's a library, but working with it, I didn't feel there was a very clear separation of here's what the library gives you, and I was looking at the code in the library, and then I was making some modifications out and implementing stuff myself, which I thought should have been in the library. So it's not very well documented, and it's still quite young. I suppose that's not a new story. So this library should be included in SDL compatible applications, and it understands SDL primitives and maintains communications with the onboard unit. And then the working parts in the onboard unit is this proxy that I mentioned, running as an operating system process. C++, it maintains communication and it's quite robust, so I think I've covered those points. The browser-based component is WebSockets interface to proxy, JavaScript library, and it's mostly design around callbacks. Okay, that's fairly simple. So that's what it is. Why we're interested in it. Getting it going. It's open source. That's available from this consortium, this Geneva consortium, which is a reasonably big auto industry consortium. They have a set of projects that they're trying to push, and this is one of them amongst, I don't know, 10, 15 other projects. They have the source code available through it. Again, it's mostly contributed by Ford, but Intel are getting involved in it. The Jaguar guys are getting involved in it. There's some kind of, let's say, smaller automotive consulting companies are getting involved in it as well. So, you know, I won't say it's got huge momentum, but there's a bit of people talking about it and trying to figure out what they can do with it. So the OBU side, what did I mean by that? Has its own HMI. I don't know, my brain just turned off there. Oh, sorry, I'm talking about what the components of the code are. So the OBU side has a web-based part, and then the mobile side has a demonstrator application. So I'll show you some of that stuff a little bit later. Did I talk about? Yeah, so compiling it and stuff was maybe just going into more detail than you guys really care about. It's uses CMake to build it, probably because they wanted to run on multiple different platforms, embedded world, etc. Didn't compile out of the box on either Tizen or Ubuntu. There was issues around Bluetooth and WebSockets SHA calculation, actually, which was quite bizarre, but there was some strange libraries that they're using there. The build generates a binary on the OBU side, which runs this proxy that I talked about and launches the HMI. They use Chromium as the default browser. And this HMI then offers the main automotive UI, which you'll see a little bit later, and a way of emulating the buttons in the car. So, and then on Android, it was fairly straightforward to build it on Android. There was a library and the application. That's probably hardly even an issue. With when you use it with Bluetooth, which I haven't used it with Bluetooth very much at all. Using it with Wi-Fi, you have to tell the device. You have to tell the application the IP address of the device it's talking to. So they don't really have discovery resolved in it when it's used over Wi-Fi, which is a bit of an issue. So then you have to explicitly put in the IP address. Some of the limitations of it. The control over the in-car display is very limited. So this probably comes from its history. So when it was used as this Ford Uplink stuff, the Ford Uplink display only has a small amount of text on the display, which can be used. This really meant that you could only use very simple text-based. You could only output very simple text-based information to the driver. In its current incarnation, this is a really significant limitation, obviously. Now, this is not any big insight, so the guys know about this, and they're trying to address some of these issues, but it's still early days for it. So, in our case, I'll talk about that in a few minutes. We had to implement logic on the OBU side to describe how to render the information that the application needed to render. So our vision of the mobile controlling everything in the car just being a placeholder for displaying the information, it wasn't as simple as that. There's no real graphic support in it. Navi integration is something that I talked about earlier. This SDL stuff doesn't really have Navi integration. They have done, they're in the SDL, there's a way of encrypting the information so that Ford has done stuff with some of its partners which is not part of the public API, and they have done exactly that, sending points of interest to the Navi, but it's not publicly available on the APIs yet. So features supported. There are features which are mentioned in the protocol, but they're not yet implemented. So it's about transferring vehicular data from the car to the app. There's file transfer stuff as well. Okay, so we were working furiously, myself and Jacek, over the last couple of hours. We had a lot of problems, so we didn't get our demo of this stuff working, so which is a bit disappointing. But I'll just talk about what we did and what the problems we had with it were. So we wanted to develop a basic application which integrates with Google Calendar, and you can see Google Calendar information in your car. So not going to talk about the Google Calendar stuff. I mean, that's, I suppose, reasonably well quite complex, but reasonably well known. So the idea was that it just takes your next upcoming appointments off your primary calendar and shows the next 5 appointments, and then you could navigate. You could browse through them by pressing the buttons on the steering wheel in the car. So you could just go on to next appointment, next appointment, next appointment, and it just showed the title of the appointment and the time of the appointment. And then you could click OK on the steering wheel, and it would just flash up the map, and it would route you to the appointment. So that was the basic idea. It assumed the location data in the Google Calendar event. So I guess a lot of you probably know that, you know, that's not in very many events, but okay, for the purposes of this demo, we were assuming that. And then use the in-car controls to control the application. So the car has a display in-car controls. The app logic is running on the mobile. This SDL protocol is for communicating between them and then communicating back to Google Calendar in the cloud. So developing it, we had to change the HMI, so the browser-based visuals that are provided. So we had to change the default application behavior. So the way this it has been developed is they have this idea of only 2 template applications for content layout. And one is a media app which just shows like buttons for fast forward and play, etc. And one is a non-media app which just shows 2 lines. So it's very, very basic. So we had to change this to show our appointment related info. So and also the map view. It was implemented using Ember.js, so strong state-oriented approach for those of you who know Ember.js. We had to add obviously new states for calendar views and map views. Ember.js has a strong model view controller design. One of the issues that we had in this kind of development was that we wanted kind of the control to be on the phone, but certainly the view to be on the car. So like the model view controller idea was a kind of somehow distributed model view controller, which basically didn't work. Like, you know, so strong model view controller design. What I mean by that is that the data models, the JavaScript app was written so that the data models were on the OBU, and we had to send the data from the phone. So it kind of was a little bit problematic. It meant the logic was much more split. So yeah, okay. So contents. Then there was observables to update the UI view when the model in the JavaScript side was updated. On the Android side, we had the SDL mobile functionality comprises of a service, an Android service, and an Android activity. So the service is communicating with the OBU. I guess is fairly standard stuff, really. Regular checks if the OBU is available, starts the activity if it's not active. The library wasn't really well coded, as I talked about earlier. Poor documentation, separation between the protocol, the library and the application wasn't obvious, so we had some issues with that. Some of the hacks that we used. We transferred the appointment or the event information from the mobile to the car, and in the protocol there was 4 lines of text were allowed in this show data message. We hid some of that text just to show the location of the coordinates of the map. So it wasn't really using it in the way it was intended to be used, but it was. The best way to use it, given or we felt, given what the primitives the protocol provided, rendering of next appointments, updates info relating to next appointments. I don't know what I meant by that. And then change to map view, realize by sending specific message show. So what I mean by this is that instead of sending information saying that this appointment or event is titled this and has this time, I sent a piece of content which says show map view, and then it just changed to the map view. So it wasn't actually sending any appointment related information. So it was quite hacky. Final thoughts on SDL. It remains unclear if it'll gain momentum. So this is some of the stuff that relates back to what Piotr was talking about. Solutions will likely evolve to HTML5. So right now they're not really there in this SDL world or in the MirrorLink world, and we think something in between will be the HTML5 solution, where you get a bit of real estate in the car and you can control that from the mobile. Developer tools need to evolve, for heterogeneous platforms, both in mobile and car, and distributed model view controller was an idea that was just going through my head. So that's the smart device thing. So we have a couple of things we're going to show you. Are you going to? Okay, we're not going to go through the Tizen.
Later.
Do it later. Yeah. Okay.
You can talk about it a bit.
Okay, so Jacek is going to set up. We've got a Tizen IVI VM here, which has the SmartDeviceLink stuff compiled for it. And we've got the mobile app here, which is using this SmartDeviceLink tester. So this is just a simple app for controlling, testing the control function of the phone. What we see here is something that came out of Ford. So this is all pre-packaged stuff. The stuff we were trying to get working, we didn't get working, but this is stuff that demonstrates basically how it works. This is a UI developed by Ford specifically for demonstrating this SmartDeviceLink functionality. So there's a lot of nice graphical components there, but it doesn't actually do very much in terms of you can't click on go to Main Street, or you can't click on the weathery stuff. What you can do is go into I there, Jacek, maybe, yeah. So here's the column on the right hand side is the list of applications that are known about. So yeah. So what's happening here is he selected an application that can be done via the components on the car as well. And when he clicked on that application via SmartDeviceLink, the service on the Android phone got the activity working, and the activity was instructed to play out some standard audio that's used in this demonstrator. So now he can send information from the phone back to the car. I think he's going to do that now. So there's quite simple message protocol which enables communication between the mobile and the car over Wi-Fi. It also has streaming support, so you can stream audio from the phone and it gets played out on the car, and that's one of the bigger use cases of it. And then when you have button presses there, those buttons and the OK, when you do those button presses, the app is notified as well that's taken place. So that's kind of the basics of how it works. What we had done is we replaced the there's an alert that just popped up. What we had done is we just replaced the screen real estate there, where you've got the user interface for the media controls. We just replaced that with the appointment information, and then you could, when you click on the OK button, just a map view appears all over that. So it was simple enough, but we had some problems at the last minute. So I think I've talked for long enough. So
I just exited from the application, and it's automatically moved out. So it's no longer there. So the second presentation in this.
Do you want to take the mic?
No, I'm fine. I just cannot duplicate my screen.
People looking at the screen can use it.
Yeah, but I need to see. I need to go into settings. Okay. Just that. What you can see here are Tizen web applications that are already installed. One of which is one developed, compiled by myself. So this I'm basing on one supported by Tizen already. That is a test go. that is a simple Go game. I can run it here.
A microphone.
Yeah. Yeah. So just to repeat, you can use, as I said before, Tizen IDE to build the applications. So there is a sample application provided with Tizen SDK, which is Go game. So if you run it here in a simulation environment, it's based on Chromium, so you can see the game. It should start right now. Okay, it's a bit big, but it's there. So what I did was I put it into the TPK file, which is Tizen packaged application. I uploaded into this IVI environment here. I will need to write down the exact name of. Maybe I got something here. No. Okay, let me just disconnect for 1 second. I will show you that you are able to run this application on IVI. Yeah, because I cannot duplicate it. Okay, if I run this. Oh, it doesn't work. I have to do it once more. Sorry for that.
He's only got one screen active, that's why he disconnects.
Yeah.
So if you can't see what he's trying to do.
It's not top secret. Okay, hope it works now. Yeah. So the same game that you've seen in the SDK. The same application, the same game application you've seen in SDK, you can see now running in the IVI environment, which is pretty cool. It's the same code, you use the same file. Okay, so this is.
It's not integrated with the development tools. It's
Which
not integrated with the Tizen development tools, so you had to sign this and you had to.
Yeah, we need to sign it and upload it into this environment manually, but it's working in here as well. Okay, so I think we're on time or slightly. We're over time, just in time to finish. So thanks very much. And if there are any questions regarding the slides or demos that you have. Yeah.
You said that HTML5 is used for communication in this solution.
I mean, as a UI, and not as a communication. It's not a native application that you use. It is browser based. Okay, thanks very much for your attention.